Hello students! In our previous video, we learned how to calculate the theoretical probability. If you can recall, in our this fractional probability, the numerator is the number of favorable outcomes to that event and the denominator is total number of possible outcomes. We also know that theoretical probability is useful in cases where the repetition of an experiment is difficult and needs to be avoided. We calculate probability by making certain assumptions. We assume that all the outcomes of the experiment are equally likely. That is, probability of all the outcomes is equal. For example, while throwing of a dice once, what is the probability of getting face with number 4? Here each number has equal possibility of showing up. That is, there are equal possibilities of getting outcomes of face with 1, 2, 3 and so on up to 6. Thus, there are total 6 equally likely outcomes when we throw a dice, which we write in denominator as per our formula. Now we are looking for one outcome, that is probability of coming 4. Therefore, the theoretical probability of getting 4 is 1 upon 6, where 1 is number of favorable outcome, that is getting face with 4, and denominator is all possible outcomes, that is getting all faces. But the question was, are the outcomes of every experiment equally likely always? Let's see. Suppose a bag contains 4 red balls and 1 blue ball. And now you want to draw a ball from the bag, but without looking at it. What are the possible outcomes? Yes, it can be a red ball or it can be a blue ball. But are the outcomes, that is possibility of getting a red ball and a blue ball, equally likely? No, of course not. And how? Let's see. Since there are 4 red balls and only 1 blue ball, we are more likely to get a red ball than a blue ball. That is, probability of getting red ball is more than probability of getting a blue ball. So the outcomes, a red ball or a blue ball coming, are not equally likely here. However, the outcome of drawing a ball of any color from the bag is equally likely. I mean, when we draw a ball, any colored ball can come. If that is our event or that is what we are looking for, then the probability of any ball coming is equally likely. So students, we can conclude from this example that all experiments do not necessarily have equally likely outcomes. Then what about calculating probability of such outcomes? Well, you don't have to worry about calculating probability in such cases. For your exam point of view, you will assume that all experiments have equally likely outcomes and use the formula of theoretical probability to calculate them. So let us see one example. A bag contains a red ball, a blue ball and a yellow ball, all the balls being of the same size. Now Kritika takes out a ball from the bag without looking into it. What is the probability that she takes out the yellow ball, the red ball or the blue ball? Now Kritika takes out a ball from a bag without looking into it. So, it is equally likely that she takes out any one of them. Now let us say we want to calculate probability of taking out yellow ball first. So let us denote this event of taking out yellow ball as Y. That is, Y be the event. The ball taken out is yellow. Now the number of possible outcomes, since they are all equally likely, is 3. That is, it may be a yellow ball, it may be a red ball or it may be a blue ball. So we write down 3 in the denominator and we want to calculate probability of yellow ball. So we write 1 in the numerator. And thus, the probability of event Y, that is getting yellow ball, is 1 upon 3. Similarly, let us say B is the event the ball taken out is blue. And so the probability of this event will be again 1 by 3. And similarly, the probability of even that the ball taken out is red, say R, is also 1 by 3. Now students, here if you observe that one event, that is taking out of ball being yellow or being blue or being red, has only one outcome, that is yellow ball can be yellow and nothing else. A blue ball can be blue and nothing else. In such cases, when there is only one outcome of the experiment, it is called as an elementary event. So here in our example, all three events, that is event Y, B and R, are elementary events. Now students, we know that for any experiment, the sum of probabilities of all the elementary events in that experiment is always 1. And this is true for all kinds of probability. Students, we can observe that here, like in our example, if you add all three probabilities, you will get their sum as 1. And thus we can say that it is universal that for all kinds of experiment, the probabilities of elementary events is always 1. But now students, what are the different types of events that we study in statistics? We will see in our next video.